If you get hold of two magnets and you push them, you can feel this pushing between them. Turn it around the other way and they slam together. Now, what is it, the feeling between those two magnets?
What do you mean, what's the feeling between the two magnets?
There's something there, isn't there? I mean, the sensation is that there's something there when you push these two magnets together.
Listen to my question. What is the meaning when you say that there's a feeling? Of course you feel it. Now what do you want to know?
What I want to know is what's going on between these two bits of metal.
Magnets repel each other.
And well, then what does that mean, or why are they doing that, or how are they doing it?
You're asking.
I must say, I think that's a perfectly reasonable question.
Of course, it's a reason. It's an excellent question. Okay. But the problem that you're asking.
리처드 파인먼은 전 세계적인 물리학자입니다. 그는 1942년 원자폭탄 제조를 위한 맨하튼 프로젝트에 참여하였습니다. 그리고 1965년 양자전기 역학 이론을 개발하여 노벨 물리학상 수상을 하였습니다. 그는 한 인터뷰에서 질문을 받았어요. 그리고 이미 여러분들이 보시다시피 굉장히 언짢아했는데요. 왜 그는 이렇게 대답을 했을까요? 여기에 우리가 반드시 새겨들어야 할 귀중한 가치가 담겨 있습니다.
You see, when you ask why something happens, how does a person answer why something happens? For example, Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. That satisfies people. It satisfies, but it wouldn't satisfy someone who came from another planet, knew nothing about things. First you should understand why, when you break your hip, do you go to the hospital? How do you get to the hospital when the hip was broken? Well, because her husband, seeing that she had the hip was broken, called the hospital up and sent somebody to get her. All that is understood by people. Now, when you explain a why, you have to be in some framework that you allow something to be true. Otherwise, you're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. Not always. Some husbands aren't interested in their wives' welfare when they're drunk and they're angry. And so you begin to get a very interesting understanding of the world and all its complications. In order to if you try to follow anything up, you go deeper and deeper in various directions. For example, you could go, why did she slip on the ice? Well, ice is slippery. Everybody knows that, no problem. But you ask, why is ice slippery? That's kind of curious. Ice is extremely slippery. It's very interesting. You say, how does it work? You could either say, I'm satisfied that you've answered me, ice is slippery, that explains it. Or you could go on and say, why is ice slippery? And then you're involved with something, because there aren't many things as slippery as ice. It's very hard to get. Greasy stuff, but that's sort of wet and slimy. But a solid that's so slippery? Because it is in the case of ice that when you stand on it, they say, momentarily the pressure melts the ice a little bit, so you got a sort of instantaneous water surface on which you're slipping. Why on ice and not on other things? Because ice expands water expands when it freezes, so the pressure tries to undo the expansion and melts it. Is capable of melting it. But other substances contract when they're freezing, and when you push them, they're just satisfied to be solid. Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult the why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after a while. That's my idea, that the deeper a thing is, the more interesting it is. And we could even go further and say, why did she fall down when she slipped? That has to do with gravity. It involves in all the planets and everything else. Never mind. It goes on and on. Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force. And you say, but that's very strange, because I don't feel kind of force like that in other circumstances. When you turn them the other way, they attract. There's a very analogous force, electrical force, which is the same kind of a question. And you say, that's also very weird. But you're not at all disturbed by the fact that when you put your hand on the chair, it pushes you back. But we found out by looking at it that that's the same force, as a matter of fact, the electrical force, not magnetic exactly in that case, but it's the same electrical repulsions that are involved in keeping your finger away from the chair, because everything's made out of its electrical forces in minor and microscopic details. There's other forces involved, but this is connected to electrical forces. It turns out that the magnetic and the electric force with which I wish to explain these things, this repulsion in the first place, is what ultimately is the deeper thing that we have to start, what we can start with, to explain many other things that looked like they were, everybody would just accept them. You know, you can't put your hand through the chair, that's taken for granted. But that you can't put your hand through the chair, when looked at more closely, why? It involves these same repulsive forces that appear in magnets. The situation you then have to explain is why in magnets it goes over a bigger distance than in ordinarily. And there it has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force until it's large enough at a distance that you can feel it. But it's a force which is present all the time and very common, and is in a basic force of almost, I mean, I can go a little further back if I were more technical, but at an early level, I just have to tell you that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion, or electrical attraction, magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. For example, if we say the magnets attract like as if they were connected by rubber bands, I would be cheating you. Because they're not connected by rubber bands, I shouldn't be in trouble. You'd soon ask me about the nature of the bands. And secondly, if you were curious enough, you'd ask me why rubber bands tend to pull back together again, and I would end up explaining that in terms of electrical forces, which are the very things that I'm trying to use the rubber bands to explain. So I have cheated very badly, you see. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do. And to tell you that that's one of the elements in the world of different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others. And those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately. That our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.
저는 가끔 부모님의 손을 잡고 가는 어린아이들을 물끄러미 볼 때가 있습니다. 아이들의 공통점은 항상 호기심이 많죠. 세상 모든 것에 신기해하는 아이들은 항상 부모님께 질문합니다. 엄마, 아빠, 이거는 왜 이런 거예요? 하지만 부모님은 무뚝뚝한 표정으로 몇 번 대답을 하다가 결국 무심하게 이렇게 대답하죠. 나도 모르니까 이제 그만 물어봐. 몇 번 대답을 해주고 결국 듣는 둥 마는 둥 건성으로 대답하고 대화가 끝나게 돼요. 우리는 어린아이 때 모든 것에 호기심을 갖고 살아갑니다. 하지만 이 호기심이 벽에 부딪혔을 때 조금씩 현실에 순응하기 시작하죠. 어릴 적 그 많은 호기심이 사라지고 그냥 원래 그런 거야 라고 생각하고 넘어가게 됩니다. 그렇게 우리의 잠재 능력을 더욱더 펼칠 수 있는 기회를 상실하게 되는 거죠. 하지만 세상은 달라졌어요. 이전과 비교할 수 없을 정도로 유용한 정보가 넘쳐나고 있습니다. 그 어린아이 때 갖고 있었던 그 호기심을 충족시킬 수 있는 수단이 너무나 많아졌어요. 몇 번의 클릭과 타이핑으로 세상에 있는 많은 지식들을 얻는 시대가 되었습니다. 저도 콘텐츠를 만들면서 정말 감사한 마음이 들더라고요. 정말 방구석에서 세계적인 석학의 인터뷰를 볼 수 있는 것은 정보화 시대에 누릴 수 있는 특권입니다. 끊임없는 의문점, 호기심을 충족시킬 수 있는 최첨단 무기가 생긴 겁니다. 그렇다면 우리는 이를 적극 활용해야죠. 리처드 파인먼은 그 주제에 대해서 너무나 해박하게 알고 있기 때문에 이렇게 간편하게 질문하면 어떻게 대답해야 될지를 모르게 되는 거죠. 제가 인터뷰 컨텐츠를 진행할 때도 생각보다 질문이 어렵더라고요. 질문자는 질문을 정말 잘 디자인을 해야 내가 원하는 답변을 정확하게 얻을 수가 있어요. 질문이 모호하게 되면 답변도 모호하게 되죠. 심지어 한 분야의 노벨 수상자에게 자석이 왜 서로 밀어내는지 질문하게 되면 굉장히 답변하기가 어렵죠. 이는 단순히 한 문장으로 답변하기가 어렵기 때문입니다. 질문자가 어떻게 질문하느냐에 따라서 한 문장으로 말할 수도 있지만 실제 그 본질에 다가가기 위해서는 책 한 권을 써야 될 수도 있습니다. 그렇기에 원하는 답을 얻기 위해서는 올바르게 질문을 디자인해야 됩니다. 리처드 파인먼은 물리학적 관점으로 세상의 왜라는 질문으로 한 평생을 바친 사람입니다. 정말 다양한 주제와 방향으로 꼬리에 꼬리를 무는 방식으로 스스로에게 질문하고 답변했을 것입니다. 어떤 분야든 본질을 깨닫기 위해서는 왜라는 질문을 끊임없이 해야 됩니다. 설령 나의 지식과 능력이 한계점이 있고 더 깊게 내려가지는 못하더라도 왜라는 질문에 답하는 범위를 차근차근 넓혀가는 것이 중요합니다. 그게 고스란히 나의 능력이 되기 때문입니다. 어렸을 적 다양하게 관심이 있었던 호기심을 유지하고 왜? 라는 질문을 해보면서 답하는 범위를 넓혀나가 보시기 바랍니다. 그것이 내가 다른 사람들보다 그 분야에 대해 더 전문가가 될 수 있는 유일한 방법입니다. 여러분들의 성공 마인드 동반자 작심만일입니다.